Hello guys, and today let's learn about Vieta's formulas. Vieta is actually the name of the mathematician actually called François Viet, who is from France obviously. Vieta's formulas can be used to relate the sum and multiples of root which equals to two solutions of quadratic equation to its coefficients. So there is also cubic, quartic, and I believe quintic available, but today we're not gonna even talk about that. It's only gonna be quadratic today. And let's talk about some examples. So for instance, we have a quadratic equation looking like ax squared plus bx plus c, which will lead to 0. And this is actually a standard form of the quadratic equation. And if we factorize the terms, let's say it'll become a because it's the coefficient of x squared, x negative alpha times x negative beta, which is 0, and this basically means that alpha and beta is going to be two roots, which is it means that there's going to be two solutions of this quadratic equations. So if you expand those brackets out, it'll become a looking something like this. Oopsie, I forgot that. Which will lead to 0. And so basically, let me write this with red pen. So negative alpha plus beta, this is the coefficient of x for now, equals to b divided by a because of this. But there's also a here, so it needs to actually divide in order to make this as equivalent. So that's a thing. And next one is going to be the alpha times beta, and those will make as same as c divided by a because this and this is the same amount. Also, this makes to divide by a to make it equivalent. So this is basically two formulas: alpha plus beta, which is negative b divided by a, because I just moved to minus sign to here because the standard form actually looks like it, and alpha times beta makes to c divided by a, and this is basically two formulas. So if I sum it up, there's gonna be so if I sum this whole thing up, there's going to be sum of the two roots are negative x coefficient divided by x squared coefficient, and the multiple of two roots are going to be the positive constant coefficient divided by the x squared coefficient, and this is the easy way I can sum it up. And yeah, for this formula. And so let's take a look at some examples. For example, our quadratic equation. Let's say, let me just take some example just using different colors. Let's say it's x squared negative 3x positive 2, which will lead to 0. So this is example. And we also need to know two solutions by factoring them. So it'll become x negative 1, x negative 2, which is 0. So this means that x is 1 or x is going to be 2 for this equation. And let's add them in order to get the coefficient of b, because the x squared coefficient is 1, so we don't really need to divide it by a because a is 1, which will make no sense. So if you actually add them and make a minus, there should be the coefficient of b for this question, which is going to be 3. Sorry, negative 3, right? Because this whole thing is negative 3, and this negative 3 is negative 3, and that actually works too. And if you actually times these two roots, it'll become 2, and which is actually matching us for this as well. And yeah, this is all the thing that it is about for Vieta's formulas. Now it's proved by the example, right? So this was the introducing how the Vieta's formula applies to this quadratics, and thank you for watching. And